Stearic acid is natural occurring saturated fatty acid, widely used in cosmetic and personal care products, particularly moisturizer. It is derived from animal fat and vegetable oil, such as palm oil and coconut oil. As a long-chain carboxylic acid, stearic acid functions as an emulsifier, thickening agent, and emollient. It also helps to stabilize formulation and improve texture and keep the skin soft and hydrated. This presentation focuses on the organic chemistry of stearic acid, including its chemical structure, properties, function in moisturizers, and cosmetic application.
There are some important organic reactions. First of all, we have acidification, where stearic acid and ethanol will react to produce ethyl stearate and water. Next, we have neutralization, where stearic acid and sodium hydroxide will produce sodium stearate plus water. And the last one, we have reduction, where stearic acid will become stearyl alcohol. So now I will talk about the chemistry explanation of stearic acid. First of all, the chemical structure is C17H35 COOH, and then the physical and chemical properties are white, waxy solid, which is insoluble in water but soluble in organic solvent. The melting point is 69 degrees. The preparation of stearic acid is obtained by hydrolysis or saponification of animal fats and vegetable oils that contain triglyceride. The intermolecular interactions is hydrogen bonding between carboxyl group, which has a high melting point and solid texture. The reaction mechanism of the COOH group reacts easily to form esters with alcohols, salts with bases, or reduce to alcohol.
Next, we are going to talk about real-life application of Kiehl's Facial Ultra Cream. For Part A, Cosmetic and Skincare Industry. Kiehl's Ultra Facial Cream is widely used as a facial moisturizer. Organic compounds such as glycerin and squalene help keep the skin hydrated by attracting and retaining water. This improves skin softness and prevent dryness. So, hi Sophia. Right now, I want to ask you why you use moisturizer.
I use moisturizer to prevent my skin from becoming dry, especially when staying in air conditioned room for so long.
So, from the interviews, the moisturizer is very important to us because the cream helps individuals with dry or sensitive skin by strengthening the skin barrier and reducing moisture loss. Dermatologists often recommend moisturizers containing glycerin and squalene to maintain healthy skin. For part C, daily life application. Many people use moisturizers daily because environmental factors such as air conditioning, sunlight, and low humidity can cause skin dehydration. Kiehl's Ultra Facial Cream helps maintain skin moisture throughout the day. So, for part D, we're going to talk about the organic chemistry behind the product. The effectiveness of Kiehl's Ultra Facial Cream is due to the organic compounds. First, we have the glycerin, which is the alcohol that can attract water to the skin. Second, we have the squalene, which is the hydrocarbon derivative that will prevent the water loss. And last one, we have the urea, which is the amide compound to improve moisture retention and softness skin. For number four, we have stearic acid, the stabilizer, which is a long chain saturated fatty acid that acts as an emulsifier and thickener. Second, it helps to strengthen the skin barrier by replenishing essential lipids. Next, it also helps to mix water and oil component into a stable, creamy emulsion. Last, it also can help to leave the skin feeling soft, smooth, and physically protected. For the molecular structure overview, we have glycerin, squalene, urea, and stearic acid.
And now I will talk about the reaction, reactant, products, and significance of this chemical equation. First, we're going to talk about hydrolysis of stearic acid. Stearic acid is usually extracted by breaking down vegetable oils or animal fat using high pressure steam. So this will be the chemical reaction. The reactant for this chemical reaction is glyceryl tristearate plus water, and the product will be glyceryl plus stearic acid. The significance of this hydrolysis is this reaction produces the raw stearic acid needed for manufacturing. The byproduct, glycerol, is also kept in moisturizers as hydration humectant. And the next one is creating the lotion, which is neutralization reaction. The process is in the mixing tank. Some stearic acid is reacted with an organic base to form a soap-like molecule directly in the formula. So this will be the chemical reaction. The reactant is stearic acid plus triethanolamine, and the product will be triethanolamine stearate, which is organic salt. The significance of this reaction is it will create as emulsifier. It binds the water and oil phases together so that the moisturizer doesn't separate into layers. And now I'm gonna sum up the summary of equation that I just talked just now. First, stearic acid is an 18 carbon saturated fat acid. It features a polar water loving head and long nonpolar oil loving tail. It functions as emulsifier, a thickener, and emollient. It also mimics the skin natural lipid barrier to lock in deep hydration and protect from dryness.
So for conclusion, stearic acid is an important organic compound widely used in moisturizers due to its unique chemical structure and properties. As a saturated fatty acid, it functions as emulsifier, thickening agent, and emollient. It also improves the stability, texture, and moisturizing performance of cosmetic products. The effectiveness, safety, and compatibility with other ingredients make stearic acid a key component in many skincare formulations, including products such as Kiehl's Ultra Facial Cream.